Hey guys, so it's Friday. You took a quiz yesterday. I am out today because hopefully I am getting my middle one, my 7-year-old, into the ortho because he needs a cast because he broke his arm at school on Wednesday. Poor baby. But you guys need to learn percent composition today because I've been reminding you guys, bring a penny. We're doing a lab on Monday, and the lab is over percent composition. So you need to be somewhat familiar with this concept before Monday, which, by the way, bring a penny 1982 or later by Monday. The time is here. I've been talking about this for weeks, it feels like. So to find the percent composition of a compound, first of all, you can see these practice problems. We've done these in class together at some point. These are mole conversions. Okay, conversion means you want to convert from one unit to another. Percent composition is a different concept, and it's actually a lot easier. So don't stress that you're learning this from a video today. So to find the percent composition of a compound, you want to get the percentage of a compound that's made up of each atom or each element. Okay, so you already know how to calculate percent, right? If you took a quiz and you graded it, to get your grade, you could take the numbers you got right and divide it by the whole amount of numbers and then multiply by 100. Percent composition of a compound is the same thing. The mass of each element, right? Whether you have one element or 6 elements, you add them all up, divide it by the whole mass of the compound, the molar mass, and then you always want to multiply by 100 because this is going to give you a decimal and you want it in percents. So let's just jump into some practice problems. That's how you're going to learn this. So it says give the percent composition of all the elements. Okay, sometimes I might ask just for one of the elements, like just sodium or just bromine. So for sodium bromide, we need to figure out the percent of that compound that's made up of sodium and the percent that's bromine. Okay, and it's not 50% sodium and 50% bromine because they weigh different amounts. Okay, so we first need to get the mass of the whole compound, the molar mass, and you get that from the periodic table. A sodium weighs 22.990 and a bromine weighs 79.904. Okay, and we have just one of each, so that makes it kind of nice. Remember, you are more than welcome to stop your molar masses at 2 decimals in. And bromine was 79.90. So when you add those up, you get 22.99 plus 79.9, 102.89. Okay, so if I were to ask you for the molar mass of this compound, you would say 102.89 grams per mole, and that would have been the end of it. But I want the percent composition. So now you take the mass of each part and divide it by the whole. Okay, so 22.99 divided by 102.89 and 79.90 divided by 102.89. Okay, you got to remember to multiply each by 100. And I kind of didn't leave myself very much room. For sodium, I get 22.34%. Take it 2 decimals in for me. For bromine, I get 77.66%. Okay, and always put the units. You want percent and sodium. And always circle your answer for me. Okay, so this would be your final answer. 22.34% sodium, 77.67% bromine. It's so much bromine, guys, because bromine weighs so much. Okay, sodium's a lot lighter than bromine, so it takes up a lot of the mass of the compound. So let's do one that's a little more challenging because you have multiple atoms in there. So we want to find the percent composition of copper 2 hydroxide. If you were to write this compound, you would have gotten copper with the 2 plus because of that Roman numeral. Hydroxide you would have to look up on your polyatomic list. There he is right there. OH -1. And then you would get copper hydroxide, CuOH2. Okay, so we need to break it down. I've got 1 atom of copper, 2 oxygens, and 2 hydrogens. Okay, and the reason I'm doing this is because I need to get the masses of each and get the total mass, the molar mass. Okay, so copper is right here. He's got a weird symbol, 63.55. I have 2 oxygens, and they're 16 each. And 2 hydrogens at 1.008. So when you add that up, you get, I should have had this done beforehand, but I didn't. I'm going to let you see how I do this in my calculator. I'm just going to clear it. 63.55 plus, I open a parentheses, 2 times 16, plus, open another parentheses for the hydrogen, 2 times 1.008, and then I press enter, and I get 97.57 grams per mole for my molar mass. Okay, so if I had only asked you for molar mass, you would have been done. 97.57 grams per mole. But I want the percent of copper, oxygen, and hydrogen. So you divide everybody by the whole, divide every part by the whole. Okay, and then don't forget to multiply by 100. You won't very often get a percent that's like a 0.22 or something. Okay, so if you get a really low number in the decimals, you probably forgot to multiply by 2. So then I just go through and plug all that into my calculator. So 65.13% copper. I already know 2 times 16 is 32, so I'm taking a shortcut. 32.80% oxygen, and then hydrogen. Again, another shortcut. I know that one off the top of my head. So maybe you don't know this, but if you just move the decimal 2 times over, you get your percent. But you would also, if you don't want to do that in your head, you don't want to forget to multiply by 100. So hydrogen is 2.07% hydrogen. So this is your answer. This is your final answer for percent composition. 65.13% carbon, 32.80% oxygen, and 2.07% hydrogen. So I want you guys to try aluminum sulfate. Okay. And then, so you do that, I will upload the key to these notes online. Okay, so on the same day that you access, on the week at a glance that you access this video, I'll have the notes key. Okay, I also want you in class to try numbers 1, 2, and 3. Okay, so try number 3 on the practice problems and check your answer on the notes. And then in class, just before you leave, you also need to do numbers 1, 2, and 3, the percent compositions of each of the elements. Also, you can check the notes for the key. Lastly, guys, I'm not assigning these to you yet, but just notice sometimes it's going to ask for the percent of just one element. Okay, so then you would just, you still have to do most of that work, but you would just circle sulfur for me instead of sulfur and oxygen. So remember to bring a penny on Monday. I'm also going to put another video on It's Learning for you to watch. Tyler DeWitt, he's an awesome chemistry tutor that makes great videos for you to watch him and just see if maybe you're not understanding, if it clicks better watching him. Alright guys, have an awesome weekend, and I'll see you on Monday with your penny from your 1982 or later.